Operations teams face prohibitive costs from premium observability platforms and operational complexity from managing fragmented tooling across multiple systems. This forces you to duplicate data and constantly switch context between different tools. OpenSearch Service now addresses these challenges with a unified observability experience. You can query Prometheus metrics using native PromQL syntax directly alongside logs and traces without duplicating data. You can monitor applications with REB metrics workflows that track rate, errors, and duration. You can trace AI agent execution using OpenTelemetry Gen AI semantic conventions to understand LLM behavior. You can correlate metrics, logs, and traces in a single interface, allowing you to investigate slow traces, overlay Prometheus metrics on dashboards, and trace agent execution without switching tools. This live query architecture consolidates your observability stack and reduces costs while maintaining operational capabilities. Managing storage costs for data-intensive workloads like log analytics, observability pipelines, and time series data can become challenging when index sizes grow. Amazon OpenSearch Serverless now supports Zstandard compression codec to help you control the trade-off between storage costs and query performance. You can reduce index size by up to 32% compared to the default LZ4 codec, directly lowering managed storage costs. You can choose between two standard modes, ZSTD and ZSTD_no_dict, depending on your workload requirements. You can tune compression levels to match your specific needs, where lower levels like Level 1 provide storage savings with minimal impact on indexing throughput and query latency, while higher levels, like Level 6, maximize compression at the cost of slower indexing speeds. You can configure the codec in your index settings at creation time. This feature is available in all AWS regions where OpenSearch Serverless operates. Organizations building AI capabilities often duplicate work because teams cannot discover existing agents and tools across the organization. AWS Agent Registry, available through Amazon Bedrock AgentCore, addresses this by providing a private catalog where you can register and discover agents, tools, skills, MCP servers, and custom resources. You can catalog and discover agents, tools, and MCP servers through the AgentCore console UI, APIs, or as an MCP server accessible from your IDE. You can register resources manually or via URL-based discovery, which automatically retrieves metadata from live endpoints. You can enforce governance with approval workflows and CloudTrail, allowing administrators to review records before they become discoverable and maintain audit trails of all access. You can search using semantic or keyword queries, enabling developers to find agents by describing use cases in natural language. The registry supports IAM and OAuth-based access control and is available in preview in 5 regions. When deploying database changes to production, you face downtime risks and DNS propagation delays that prevent applications from immediately accessing the updated environment. RDS blue/green deployments with RDS Proxy addresses this by eliminating DNS propagation delays during switchover, allowing your applications to access the new production environment without configuration changes. RDS Proxy actively monitors database instances and automatically redirects connections to the green environment once it becomes production, enabling faster application recovery. You can deploy these changes via the RDS console or CLI. This capability is available for Aurora MySQL, Aurora PostgreSQL, RDS for MySQL, RDS for PostgreSQL, and RDS for MariaDB in all commercial AWS regions where RDS Proxy is supported. Monitoring and optimizing EC2 capacity across multiple accounts and resources can be difficult when you cannot organize metrics by your existing organizational structures. EC2 Capacity Manager now supports tag-based dimensions to address this challenge. You can activate up to 5 custom tag keys such as environment, team, or cost center to filter and group capacity metrics. You can use these tags alongside built-in dimensions like region, instance type, and availability zone in both the console and APIs. You can export tag data as additional columns in S3 data exports for downstream analysis. The feature also includes 4 default Capacity Manager provided tags for auto-scaling groups, EKS clusters, Kubernetes node pools, and Carpenter node pools. The new account name dimension helps you identify accounts when analyzing cross-account capacity data across your organization. This feature is available in all regions where EC2 Capacity Manager operates. Organizations running Amazon Bedrock model inference workloads need to attribute costs to specific teams, projects, or cost centers for accurate budgeting and chargeback. You can now allocate Bedrock costs by IAM principle through AWS Cost and Usage Report 2.0 and Cost Explorer. To implement this, you tag your IAM users and roles with attributes such as team, project, or cost center. You then activate these tags as cost allocation tags in the Billing and Cost Management console. Next, you create a CUR 2.0 data export and select the option to include caller identity allocation data. Finally, you analyze Bedrock model inference costs by filtering on these tags in Cost Explorer or examining line item details in CUR 2.0. This capability is available in all commercial regions where Amazon Bedrock operates, enabling you to track and allocate inference costs across your organization. When replication fails due to incorrect permissions or configuration, objects could be expired or transitioned by lifecycle rules before replication issues were resolved, resulting in data loss or inconsistencies across regions. S3 Lifecycle now automatically pauses expiration and transition actions on objects that have failed replication, even when they match your lifecycle rules. You can correct your replication configuration or permissions, then use S3 Batch Replication to replicate the previously failed objects. Once replication succeeds, S3 Lifecycle automatically resumes processing these objects according to your configured rules. This change applies automatically to all existing and new S3 Lifecycle configurations across all AWS regions, allowing you to coordinate replication fixes with lifecycle management without risking premature object deletion or storage class changes.